This is a Fox San Antonio special.
For ages, we've had our eyes on the skies, recording the movements of the sun and the moon. We've created intricate calendars to predict the changes of seasons. We've watched the patterns of the clouds as they sailed over the land, changing shapes and colors, looking for clues about what the weather will bring for the next day, month, or maybe even the season. We are living, breathing, walking weather sensors, recording what we see and feel as personal stories. These personal weather stories help shape our thoughts and our ideas about weather and long-term weather patterns.
I remember my mother came out to visit from California, and I had picked her up from the airport. And we weren't sure if planes were going to come in because everything was icing over. And I had to get gas, and I stopped at the gas station and I went to grab the pump, and it was frozen to the actual to the pump. And so it was difficult to get that off. I never really understood cold until I experienced a Texas winter.
On Halloween Eve, we woke up to 28 degrees. And for San Antonio and vicinity in South Texas, that's a pretty good wake-up call to winter.
Winters have always been very special to me because my mom told me that on the day that she took me home, it was snowing. So I've always loved the winter time. I'm a fall-winter kind of guy. I remember when I was growing up that Halloween always meant that you had to wear a costume, but you had to wear something warm underneath. And for way too many Halloweens now, that hasn't been the case. I remember that when we would wake up on Christmas morning, we would be drinking, hot chocolate because it was cold. And it seems less and less like that's the case. I always thought New Year's was freezing. You could see your breath among the fireworks, but not so much anymore. So to me, it just seems that winter has changed.
Has winter really changed? If so, what have the changes been? And how are they impacting our winter seasons? Before we can answer those questions, we need to get a basic understanding of how the atmosphere works. The atmosphere surrounds the Earth. It has several layers, with the lowest being the troposphere and the highest being the exosphere. Almost all of the weather happens within the first 10 miles of the atmosphere. High above us, the movements of high pressure create powerful winds that whip around the Earth like a roller coaster. These rippling rivers in the sky send Arctic air masses southward on a collision course with warm tropical air headed northward. The result? Large waves of fast-moving air that rotate around the Earth. This wavy river of air is known as the jet stream.
What's happening though is as the Arctic warms so much faster than the rest of the world, that jet stream is starting to slow down and meander just like a river. When a river slows down, instead of flowing straight from point A to point B, it starts to kind of wind around like this. So the jet stream that's powered by the temperature difference between the Arctic and the mid-latitudes, the jet stream is also starting to meander. What does that mean? It means in winter, instead of whipping around the planet like this, sealing off the Arctic, in winter we're getting these huge meanders in the jet stream, and Arctic air masses are coming all the way down the Rockies, all the way to West Texas.
So it is the rippling movement of the jet stream that allows Arctic air to dive southward or to stay bottled up over the Arctic. It is the ebb and flow of this river of air that changes the weather patterns across the country. Earth is the water planet. Water covers about 71% of the Earth's surface, with most of it in the ocean. The Earth's surface is warmed unevenly by the sun. The ocean absorbs much of the solar energy that reaches the Earth and slowly releases that heat over many months or years, affecting climate and seasons. The oceans can store more heat in the first 10 feet than the entire atmosphere. The atmosphere and ocean are in constant motion. The atmosphere moves quickly. The ocean moves slowly. Multiple forces keep the global ocean conveyor belt or thermohaline circulation in constant motion below the ocean surface. Deeper currents are driven by differences in density. Extreme changes in sea surface height and sea surface temperature affect ocean and atmospheric circulations. El Niño and La Niña occur when changing wind patterns displace warm, cool water in the equatorial Pacific. Both have global impacts. During either of these events, the replacement of cold water by warm water leads to air temperature swings and changes in moisture levels. This changes weather patterns by steering storms and rainfall to new locations. Heat and moisture carried by the Gulf Stream northward brings warm temperatures and a moderate climate to Europe. Thunderstorms are a frequent occurrence in the tropics. Some of these may organize into large rotating systems with strong winds, growing into tropical storms or hurricanes. Tropical ocean basins like the Caribbean and the Gulf of Mexico absorb plenty of heat, making these areas favorable for rapid tropical storm intensification. The oceans play a critical role in our climate system. The oceans influence climate by absorbing solar radiation and releasing heat needed to drive the atmospheric winds, by releasing aerosols that impact cloud cover, by producing moisture that falls as rain, by absorbing carbon dioxide from the atmosphere and storing it. So the key to understanding weather and seasonal change is strongly linked to understanding the ocean. Looking for long-term weather changes means looking to the past. You can't simply go back 10 or maybe 20 years. Finding a change means going back at least 100 years. The best place to start is at the National Weather Service office. Jason Runyon is a meteorologist with the National Weather Service office, Austin, San Antonio. Jason is familiar with long-term winter data.
Our official records go back to 1885. That's when we started keeping at least temperature records. Our snowfall records, accurate records, begin in the 40s. 1899 was a really cold winter here, not only here but across all of Texas. There were reports of Galveston Bay freezing over, Nueces Bay in the Corpus Christi area freezing over, and certainly this area was very cold. It was our third coldest winter on record.
The winter of 1899 was part of the greatest Arctic outbreak in history. The jet stream plunged into the Gulf of Mexico. The combination of clear skies, dry air, and windy conditions set the stage for the most severe Texas blue norther ever experienced. Temperatures plunged to Siberian levels, 31 degrees below zero across the Panhandle.
We continued pretty much that same general trend of mid-50s for average temperatures through the first part of the 20th century. When we got into the 40s, the mid-40s, we saw a brief cold spell, some cold winters in the mid-40s. So our coldest winter was the 1977-1978 winter, very cold winter, followed by the 1983-84 winter. Many people remember that here. Bitterly cold winter. We had 15 straight days of freezing temperatures here in San Antonio. So there's a natural variability to our climate. Some of it's tied to some decadal oscillations in the Atlantic Ocean and the Pacific Ocean. Some of it back in the 70s and 1983-84 was tied to volcanic ash.
So what is a decadal oscillation? Simply, it is the sea surface temperature swings between cold and warm every few decades. It happens in the Atlantic and in the Pacific. The overturning moves warm water from the tropics toward the poles and cold water from the poles toward the tropics. These ocean temperature swings can alter weather patterns throughout the world.
During the Atlantic decadal oscillations, these last 20, sometimes 30 years, those during certain phases can bring below normal temperatures. It can also be tied to active Atlantic hurricane seasons. But then there's other oscillations in the atmosphere that are smaller in scale, like the ENSO oscillation, El Nino and La Nina, that can last maybe 6 months to 18 months, and those can have effects on wintertime temperatures and precipitation. And there's even smaller oscillations in the atmosphere that are on the order of maybe 2 to 4 weeks that can affect how much of an Arctic push comes down from our poles.
The Atlantic Ocean went through a warm period in the 1930s and 1940s, and then again in the 1990s and 2000s. Both of these time periods experienced cold winters with unusually heavy snow, record-setting cold temperatures, and a drought that ran from 1933 to 1935. The rest of the 40s was near normal until 1947, when the cold returned along with drought conditions. 1949 brought two ice storms that disrupted power and communications from Amarillo to San Antonio. The coldest day ever recorded in San Antonio arrived on the last day of 1949 with 0 degrees.
One of the biggest natural cycles that affects us here in Texas is El Nino and La Nina. We know that we had a great wet El Nino year this past year, and we know that we had a terrible string of dry, hot La Nina years just a few years before that. So this pattern of dry, wet that we see as far back as we can go in history here in Texas, that comes from El Nino and from other cycles. But what's happening is El Nino is not the only game in town. We're also seeing that we're getting warmer. So we have this cycle like this, but the cycle's starting to tilt, and also that cycle is starting to get stretched.
There are many things that could impact what type of winters we experience here in Texas. The jet stream, El Nino, La Nina, the Atlantic Decadal Oscillation, volcanic ash, and smaller oscillations in the atmosphere.
Our official climate records started in 1885 in San Antonio. For the late 1800s through about 1939, the records were kept downtown. There's some unreliability in how the instruments were sited. Many of the years the instruments were on top of buildings, sometimes 5 or 6 stories up in the atmosphere. Now we like to measure our temperatures down closer to eye level. It's a little bit more reliable as far as the accurate near surface temperatures. And so in the late 1800s through 1939, our temperatures were kept downtown. They were briefly moved to Stinson Municipal Airport in 1939 and eventually to what is now San Antonio International around 1942. Our accurate snowfall records began about 1946.
So our weather records have shown that San Antonio winters have been cold, with occasional snowfalls and some that were clearly out of the ordinary, like the record snowfall of 13.5 inches that happened from early Saturday morning, January 12th to January 13th, 1985. The data from 1990 until today is eye-opening. It paints a picture of change across the state for all seasons, with summer and winter changing the fastest. A look at what our winters have become and what's in store for the future is coming up next. Looking at climate records back to the late 1800s, and we can see that we have an up and down pattern of hot, dry, and our winter seasons are cold. Cold waves, it seems, were a normal part of the winter season and were the coldest in February. In fact, a storm that stretched along the Texas coast from Victoria to Houston in February of 1895 dropped about 20 inches of snow along the coast. It seems that the turning point in our winter seasons appears to have started in the 1950s. That's when temperatures began to slowly change. That change continued all the way through the 90s.
So as you start looking from the 90s through today, we have seen a slow increase in our mean temperatures during the winter months. 17 of the past 25 years, we've seen mean temperatures above the averages all the way back to our earliest records, with only 6 years below the average. Especially the last 30 years, when you compare them to the previous 30 years and the previous 30 years before that, the temperatures are a little bit warmer than they should be.
The trends that we're seeing here in Texas are consistent with what we see across the entire United States and around the world. We know that over time, over 20, 30, 40, 50, 100 years, the Earth is getting warmer, and as it gets warmer, it's affecting the United States, and it's affecting us right here in Texas. So we're seeing our warm temperatures, we're seeing our wet conditions, and what we're also seeing is that this cycle of drought, flood, is being stretched.
So there has been a slow uptick in our temperatures since 1990, and overall we've been increasing in our temperatures. Not all winters have been warmer than normal. We've had a couple cold winters. The 2009-2010 season was a very cold winter here, our 7th coldest winter, and we actually had snow that year.
The data is clear. Temperatures have been rising slowly through the years. So if you feel winters have changed, they have. Looking back in time at the average temperature of the winter months from 1895 to 2016, we can see a clear warming trend through the years. February is warming the fastest. Does this mean that winter is going away?
We still have winter, and we're still going to see winter for a long time to come. We're also seeing our cycle of cold, hot being stretched too. Because even though our winters, on average, have gotten warmer faster than any other season, we still get crazy cold weather. Our winters are getting warmer, not just here in Texas, not just in the whole United States, but around the world. And winters up in the Arctic are warming twice as fast as they are down here. So at the same time as our winters are warming, we're also getting these crazy cold outbreaks. And the best way to think of it is, our weather always looks like this in Texas, and it's just getting stretched.
Our average first freeze date is actually about 2 days later than it used to be back in the 20th century, the middle part of the 20th century. So we're seeing a later start to our freezes, and our last freezes in the springtime are also about 2 days earlier.
This means our seasons are changing. Summer is getting longer, and winter is getting shorter. For those of us who like mild winters and long summers, it may not be a big problem. However, there are consequences to stretching out and compressing our seasons.
Up here where I live in Lubbock, we didn't used to have fire ants because our winters were too cold. Now our winters are so warm that we do have fire ants. And in fact, in terms of plants, how plants feel, Lubbock now feels like Austin did just 20 or 25 years ago. So we're seeing all kinds of invasive species that don't like cold temperatures creeping northward. We're also seeing that our growing season is starting earlier in the year and lasting longer, and we're getting that heat more frequently. So our heating bills in the winter are going down, that's a good thing, but our air conditioning bills in the summer are going up, and that's not a good thing. One of the things that we're seeing changing is our allergies in the pollen season. So first of all, the pollen season is now lasting longer, and we're also seeing that as carbon dioxide levels in the atmosphere rise, and carbon dioxide is produced when we burn coal or gas or oil, that feeds some of the worst plants like ragweed. They produce more pollen when there's higher CO2 levels than they do when there's lower. So we're seeing longer seasons and we're seeing more pollen being produced.
A warmer atmosphere also means a warmer ocean, and heat cycles in the Pacific impact our winter season in more than one way. Temperature records show a steady rise over the past 50 years in San Antonio. We're seeing and feeling that something is different. Our seasons are changing, stretching. Our winters are getting shorter. Our summers are getting longer. There are fewer days with freezing temperatures. This makes pollen seasons last longer. The change is also allowing fire ants to migrate northward and mosquitoes to stay almost year-round. These are but a few of the things that have changed along with temperatures, but there's more.
Our droughts, which come naturally when we have La Nina, our droughts are getting stronger and lasting longer because it's hotter. So water evaporates more quickly. So the soil moisture evaporates faster, the reservoirs evaporate faster now when we have a drought. And when we have wet conditions and when those storms sweep across Texas that bring those heavy rainfalls, we have more water vapor sitting up there in the atmosphere for them to pick up and dump on us if it's warmer, because in warmer conditions, water evaporates more quickly, and so it's all sitting up there waiting for that storm to come, which then picks up all of that water vapor and dumps it on us.
Other impacts that might not be so direct, so indirect with infectious diseases, being able to spread a little bit more further north and into areas that we haven't seen before because weather might be more conducive to them for a longer period of time. So for example, mosquitoes. And it's not just mosquitoes, there's other infectious diseases or pests that could get into trees, and they usually die off with cooler temperatures, such as the emerald ash borer, which has actually extended up into Canada. And the other thing with cold weather in the winter is that we have this factor of precipitation come in.
We've seen now some flash flooding during our winter months. Also with an increase in our temperatures, there's a small signal there that we're less likely to see snowfall than we were, say, 30, 40 years ago. And in fact, when you look at our snowiest winters on record, only out of the top 10, only one of our snowiest winters have occurred in the past 20 years.
Things are changing. And we know they're changing by looking back at the way it was 10 or 20 or 30 years ago. It's a lot warmer now. Let's look at what's been happening in San Antonio, for example. We're seeing more frequent extreme heat days. We know that the number of extreme heat days in San Antonio is going up. We also know across Texas our average temperatures are going up. We also know sea levels rising. We know that we're not seeing any more frequent hurricanes, but we are seeing stronger hurricanes because they get their energy from warm ocean water. We know these things are happening. And then we look forward into the future.
There's 4 ways that we can adapt, and that's behaviorally and technologically, infrastructure changes, and then physiologically. So physiologically is that acclimatization.
If you're driving down a road that's very straight, we have a lot of very straight roads here in Texas. If you're driving along a road that's very straight, you can stay on the road by looking in your rear view mirror at where you've been in the past, and it works. But if there's a curve in that road, then you can't look backwards. If you look backwards, you're gonna run right off the road. We have to put our eyes forward and look at where we're going to make sure that we stay on the road when we get to that curve. Our climate is changing. It is not stable. It is changing. And so we can't rely on the past anymore to tell us where the 100-year flood zone should be or how much air conditioning we're going to need in the summer. We have to look at how things are changing, look down the road, make sure that we're prepared so that as we round that curve, we're all okay.
Many of you have felt the warmth of summer holding on longer than usual, even getting a little uneasy and anxious as temperatures fail to cool even in the month of November. You know that something is different. Winters from the late 1800s into the 1980s were cold. Temperature records show that our winter seasons, they're just not what they once were. Our winters have changed. There's been a steady rise in our winter temperatures since the 1990s. The days of frequent, strong Arctic cold fronts are gone. They've been replaced by weak pushes of cool air. We're seeing fewer nights with freezing temperatures, and our coldest days of the winter seasons are limited to the first week in January on average. January and February are heating up, with February warming the fastest. Our seasons, once unique experiences, have blended together, becoming more tropical. The consequences are longer pollen seasons, increased insect populations like more fire ants and more mosquitoes. We're seeing higher energy bills and increased risk of flooding events. It's clear our winters are getting warmer and they're getting shorter. So, if you think winters have changed, they have.
This has been a Fox San Antonio special.